All right, guys. So this is part two of the video that is kind of giving some insight into the quiz based on the Molar Volume Lab. Now, so far, where we had left off before is we found the initial pressure of just the hydrogen gas by subtracting the water pressure from the total pressure. We also found our volume, realized that we need to change that into liters. To do that, we divide by 1,000. And our temperature is given to us as 23 degrees Celsius. We know since we're dealing with a gas, it needs to be in Kelvin. So we need to add 273. So in order to find our final volume, we need to rearrange our combined gas law using the information made available. We have our initial pressure, we have our initial volume, again, milliliters to liters. We want to add that, put that in there. And then our final temperature is going to be STP, so 273. At the bottom, our initial temperature was 23 degrees Celsius, which again, we need in Kelvin. So we add 273. And our final pressure is STP, 760 millimeters of mercury. When we do this math, we end up with 0.0319 liters of hydrogen, and that is our final volume. Okay, that we're going to need for the final volume. We're going to see that again here in just a few moments. Now, number 3 says determine the mass of magnesium, convert this mass into moles of magnesium. So we see that our mass of magnesium in this example is 0.0333 grams of magnesium. So down here at question number 3, we're going to go ahead and use that as our given 0.0333 grams of magnesium. We're going to now multiply this by the molar mass of magnesium, which is 24.3 grams. This is the molar mass of magnesium, and therefore it's going to be 0.00137 moles of magnesium. Now, that information is good and all, but remember, we're focusing on hydrogen. Well, what do we know about the balanced equation? When we look up here at the balanced equation, we see that magnesium to hydrogen, it's a 1-to-1 mole ratio. So since it's a 1-to-1 mole ratio, then we know that that means, mole ratio, 1-to-1. We know that that means we have 0.0137 moles of hydrogen. Now, that information is going to be necessary when we get down here to question number 4. Okay, question 4 says, from your answers in number 2 and number 3, determine the volume and moles of hydrogen gas. Well, volume would be in liters, and then of course we need to know how many moles it is. Well, the liters, we just determined what that is. Okay, that was up here with question number 2. So that's 0.0319 liters. And the number of moles we have, we just determined that in question number 3. 0.00137 moles. Now we do the math. We go ahead and divide these out. When we divide these out, we end up with 23.302 liters per mole. Not bad. Now let's see how close we are to the actual accepted value for molar mass, or for molar volume. So 23.302, the accepted value is 22.4. Let's multiply that by 100%. And in doing that math, we see that we are at 104.02%, which is pretty good. The goal is to get plus or minus 5%. Okay, so we're within plus or minus 5%, so that data works out pretty good. So, guys, I hope that helps. Have a great day.